This is second lecture on moment of inertia of areas. We are going to do problem type 1 in which we are required to find moment of inertia about given x and y axis. Now, in order to follow this lecture properly, you need to listen to basic lecture on moment of inertia which is already there on the site. Now for this purpose, let's take this area. And our objective, our specific objective is to find moment of inertia of this area about x-axis which is at the bottom of the rectangle and about y-axis which is at the left of the rectangle, left end of the rectangle. Now you will appreciate that this area comes about if from the rectangle we take out the two triangles. So let's see the various steps involved. It is advisable to make a column like this whose headings are number, moment of inertia, area, distance d, and the last column I plus AD square. Now area 1, I take it as a full rectangle, and for this, if you remember, the moment of inertia formula is 1 by 12 BD cube. So what we are interested is in finding initially 1 by 12 BD cube for this rectangle. Now if you do that, that is if you find 1 by 12 into B which is 100 and D which is 50, so if you do 1 by 12 BD cube, you will get the number 1041666.67, and this value is, by the basic formula, moment of inertia of this rectangle about this red dotted line. Next column is area, which is the area of this rectangle, which is 100 into 50, that is 5000. And next column is D, which is a distance between two axes. One, the red axis, that is rectangle's own centroidal axis, and second, x-axis, that is axis of interest. So distance between these two axes is 25, 50 by 2. And the last column actually is the parallel axis theorem, which is I plus AD square. And if you actually do the calculations, then you will get 4166666.67. Now this number is moment of inertia of this rectangle about the bottom x-axis, because we have done it by applying parallel axis theorem. Now what we are going to do is we are going to do the same operations for the other two triangles. So let's take the triangle number 2. Now for this, the formula is 1 by 36 BD cube instead of 1 by 12 BD cube, which is 1 by 36 BD cube. Now the red dotted line which has come is the centroidal x-axis of this triangle, and under I, the value which has come 104,166.67 is the moment of inertia of this triangle about this red axis. Under area, we are writing area of the triangle, which is simply base into height by 2, that is 30 into 50 by 2, that is 750. And then under D, we have written number 33.33. Now you see this number is distance between this red dotted line and the bottom x-axis. The red dotted line and the bottom x-axis. So it is 2/3 of 50, and that is D. And then we do I plus AD square and we get number 937,500.00. Now see, we have put a negative sign in the last column, which tells us that yes, this number is moment of inertia of this area about the bottom x-axis. That is true, but it is the area which is not there, and that's why we have put it negative. This is slightly different from the way we used to handle centroid, where we used to put area as negative. But here we let everything happen, and the end result, that is I plus AD square, we put it as negative. Same operation we are going to do for the third triangle. Third triangle formula is same, 1 by 36 BDQ. The red line which has come is its own centroidal axis. Now 1 by 36 BDQ for this triangle comes to 6666.67. Area of this triangle comes out to 300, and the D, the distance between the red dotted line and the bottom x-axis, will be 13.33. The reason is simple, because the base of the triangle is 50 minus 30, that is 20, and the distance of red dotted line from the bottom x-axis is 2/3 of 20, which is 13.33. And then we do I plus AD square, you get minus 60,000. And now that we have done the work for all three areas, all you need to do is add up the last column algebraically, and what number you get, that is 3169166.67, is the moment of inertia of this area, about the bottom x-axis. Now, as a second part of this problem, what we are going to do is find moment of inertia of this very area about y-axis. See the changes. The column is similar. When I deal with first area, I realize that now I have to deal with axis parallel to y-axis, and about this axis the moment of inertia is 1 by 12 dB cube, that is cube just interchange. See, it is 1 by 12 50 into 100 cube. If you do, you will get this number 4166666.67. Area continues to be 5000, and D, the distance between the red dotted line and the y-axis, is 100 by 2, that is 50, and then there is I plus AD square. Now, doing similar things for area number 2, which is the left triangle, what we realize is now we have to find moment of inertia about the red dotted line which is just come up on the screen. That will be again 1 by 36 dB cube, but here it will be 1 by 36 50 into 30 cube. You will get 37,500. Area continues to be 750, and the distance between the y-axis and the red dotted line is 30 by 3, that is 10. And then we do I plus AD square, and we do not forget to put negative sign because this area is to be taken out from the figure. And exactly similar operations you do for area number 3, wherein I is 1 by 12, 20 into 30 cube, area 300, and the distance of this red line from y-axis, which is at the left, is 100 minus 10, and that is 90. We do I plus AD square, sum it up algebraically, and we have the answer 14109,166.67 as moment of inertia of this figure about y-axis, which is shown, and earlier number 3169166.67 has been moment of inertia of this area about x-axis. So this is how you handle a situation when you are required to find moment of inertia of about given axis. Please note, very important, that in these like problems you didn't have to find centroid, neither it was required to find moment of inertia about centroidal axis. You can do it directly as shown here just now. Thank you.